In this video, we're going to talk about how to determine asymptotes of rational functions. So remember, vertical asymptotes will occur in an x value where the function is not defined. So a rational function will never actually cross a vertical asymptote. A horizontal asymptote will occur at a y value as the x values tend to infinity, okay? So like here you can see it has a horizontal asymptote at y equals 0 because x is heading to positive infinity and x is heading to negative infinity. So how do you determine the horizontal asymptote? It's going to depend on the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will be y equals 0. So if you see in this example, you can see that the numerator has a degree of 1 and the denominator has a degree of 2. So the degree of the numerator is less than the degree of the denominator, so the horizontal asymptote will always be at y equals 0 in that case. So that's why when we have the parent function y equals 1 over x, the horizontal asymptote is at y equals 0 because the degree of the numerator is actually 0 because it's a constant and the degree of the denominator is 1. So if the degrees of the numerator and denominator are equal, the horizontal asymptote will actually be the ratio of the leading coefficients. Remember, the leading coefficient is the coefficient of the highest degree term. So if we look at this example, you can see that the leading coefficient of the numerator is 4 and the leading coefficient of the denominator is 2. Both of the numerator and denominator are quadratic, so they have the same degree. So the horizontal asymptote is going to be found by the ratio of 4 over 2, which is equal to 2. So the horizontal asymptote is y equals 2. If the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. So in this example, you can see that the numerator has a degree of 3 and the denominator has a degree of 1. So if numerator has a greater degree than denominator, no horizontal asymptote. So you only have three possibilities, either y equals 0, y equals the ratio, or there is no horizontal asymptote. So let's look at some examples. So let's practice determining the wholes and asymptotes of the following rational function. So what we're going to do is we're going to start off by factoring everything. So the numerator cannot be factored, so we just leave it as x plus 3. The denominator will become x plus 3 times x minus 3, right? Because that is the difference of squares. So notice we have this common factor of x plus 3. So I can use that to help me figure out the location of the whole, because x plus 3, we set it equal to 0, which will give me x equals negative 3. Now let's figure out the reduced function. That's going to be f of x equals 1 over x minus 3. So if I go ahead and plug in x equals negative 3, we get f of negative 3, which is 1 over negative 3 minus 3, which is equal to 1 over negative 6. Okay, so the location of the whole is going to be negative 3, negative 1 over 6. Now let's figure out the asymptotes. So the vertical asymptote will be found by setting the denominator equal to 0, right? So I'm going to look at the denominator of this reduced function and set it equal to 0. So I have x minus 3 equals 0, which is going to give me x equals 3. That is going to be my vertical asymptote. For horizontal, I need to look at the degrees of the numerator and denominator. Here the degree of the numerator is 1, degree of the denominator is 2. So I have the degree of the numerator is less than the degree of the denominator. And remember, when that happens, that means I'm going to have a horizontal asymptote at y equals 0. Remember, you can always type this function into Desmos to verify everything that you've just found, right? So we said that we have a whole at negative 3, negative 1 over 6, vertical asymptote at x equals 3, and horizontal asymptote at y equals 0. So if we go to the graph, we can see that's what's going on. Notice as the x values head to negative and positive infinity, we have an asymptote at y equals 0. It tells us that at negative 3, the function's undefined, right? Because that's the location of the whole. And we also have our vertical asymptote, which you can see here, that is located at x equals 3. So now let's work on this rational function. Let's determine the whole and asymptotes of this rational function right here. So we have f of x equals 2x squared plus 5. So if we factor everything, the numerator becomes 2x squared plus 5 because that can't factor. The denominator is going to become x plus 2 times x minus 1. So there's no common factors here, okay? So if there's no common factors, this graph will have no whole. So let's go ahead and work on the asymptotes. So the vertical asymptote, we're just going to set the denominator equal to 0. So we have x plus 2 times x minus 1 is equal to 0. That means that x plus 2 equals 0 and x minus 1 equals 0 are going to tell us the location of the vertical asymptotes. So we have an asymptote at x equals negative 2, and we have an asymptote at x equals 1, right? So those are going to be our vertical asymptotes. Now for the horizontal asymptotes, we're going to look at the degree of the numerator and the degree of the denominator. Degree of the numerator is 2, degree of the denominator is also 2. So they're actually equal, right? So we need to look at the ratio of the leading coefficients. So the leading coefficients are 2, and remember the denominator is 1. So it's going to be y equals 2 over 1, which is y equals 2, and that is going to be my horizontal asymptote. So now let's look at the graph and verify all of this information. So you can see this is a pretty interesting looking graph, right? And the reason is because we have those two vertical asymptotes at -2 and at +1. Also, you can see here we have this horizontal asymptote at y equals 2 because notice at y equals 2, the x values are headed to infinity. You can go ahead and pause the video and try doing this example on your own. So let's determine the holes in the asymptotes of this function, which you can see here in factored form is 2 times x plus 3 times x plus 2 over x plus 3 times x minus 2. We have the common factor of x plus 3, which tells us that we have a hole with an x coordinate of -3. When we plug it into the reduced function, we get a y coordinate of 2 over 5. So now let's go ahead and figure out the asymptotes. So if we set this denominator x minus 2 equal to 0 and solve for x, we get a vertical asymptote at x equals 2. The horizontal asymptote will be at y equals 2 because notice that in the original function, the degree of the numerator and the degree of the denominator are the same. So the horizontal asymptote will be the ratio of the leading coefficients, which is 2 over 1. That reduces to 2. So now let's look at the graph. So from the graph, you can see that we have that vertical asymptote at x equals 2. And also you can see that the horizontal asymptote of y equals 2, that tells you a location where the x values are headed to positive and negative infinity.